In this lecture, I'm going to be going over how you can hook functions using something called the LD preload trick. So the LD preload trick involves hooking functions by using an environment variable called LD preload. So whenever you have a program that uses some kind of external library, it's probably going to need to resolve these symbols for external functions, and these can include functions like puts or fgets or printf or strcomp or any of those types of functions that you've used in your program that you have not defined yourself, but that you are using from an external library. So whenever we use the LD preload environment variable, this environment variable sort of contains a list of libraries that are going to have preference over other libraries. So if we modify this environment variable with our own library, and let's say our own library redefines the function puts, so it also contains a function like puts that has the same return type and the same function parameters as puts, then whenever puts is called by the program, the attacker's version of the library that we loaded using the LD preload variable will be used instead of libc's version of puts. So our version will have preference over any other version of that library. So the way that this trick works is we create our own library, and we have that library get loaded into the program when we execute it. And because our library is being loaded instead of the original library, our version of the function that we're trying to overwrite gets preferred, and we are able to run whatever code we would like inside of that function. The binary that we're going to be exploiting today is called license. So if I just run the program for you real quick, it says enter your license key when you run it. So you can type in whatever you would like here, and it will say invalid license key. So when I programmed this, I just hard coded the license key and used like a strcomp to compare the user input with the license key. So because the license key is hard coded, you could just use something like the strings command, which will print out all strings that are inside of the binary. So if you just use the strings command and scroll up, you will see that this string right here is inside of the binary. So if you just copy that string and then run the program again, and then use that string as the license key, you will get a shell. But in normal circumstances, you won't have access to this information. In normal circumstances, you'll usually have a function that maybe checks against some sort of database through the internet as to whether the license key is valid or not. And then that database will return true or false based on whether the license key is valid. And usually that's something that that's the way that programs will check and make sure that your license key is valid, because if it's hard coded like that, you could just, again, you could just use the strings command like I just did right here, and then just look at the whatever the output is of that command. Or you could also try reverse engineering it, like if it's a number or something, if it's not a string, then you could look through the program through Ghidra and see where that if statement is occurring, where it checks the validity of your input. But if it checks through some kind of internet database, chances are you don't have access to that database. So you wouldn't be able to just read through that and look at the key. So when we're exploiting this binary, just for our purposes here, we're going to ignore this, and we're going to pretend that we have no clue what the license key is. So we're just going to pretend that it, checks the internet whether the license key is valid or not. So what we're going to do is we're going to go ahead and run Ghidra, and we'll open up this program inside of Ghidra just so that you have an idea of what this program will look like and what it's doing in the background. Takes a moment to load. So looking at the main function, we can see that the very first thing it does is it asks us to enter in our license key. And we can also see there's this sort of character buffer that's 128 bytes that's just on the stack. So we use fgets to read our input into the this buffer right here. So we could just, since we know that this buffer contains our license key, we could just rename this to be the license key or something, just so that we know what it is and we won't forget. Next, we have this check license key function right here. And if this function returns 0, then it's going to print out invalid license key. Else, if it prints out, if it's not 0, then it's going to give us a shell and allow us to execute code. So if we look inside of this license key function right here, this is where the stir compare is occurring in the side of this do while loop. Whenever you use stir compare, it just automatically uses a while loop to compare each byte inside of the string. And that's why you see this do while loop here occurring. It's because that's how stir comp does it. But when I originally programmed this program, I just use star comp to compare it against to compare the input against this right here. And if it was equal to the input, I just return 1. But again, in normal circumstances, this is going to check against some kind of internet database, and we would have no idea what the actual license key is, and we wouldn't just be able to modify it. We wouldn't be able to just look at it right here. We would have to, hook a function like I'm about to show you right now, and have our function be executed instead. So let's just pretend that we have no clue what this check license key function actually does. So if we go ahead and get out of Ghidra real quick, let's open up an object dump of this license program. So this is what the license program is going to be looking like inside of our assembly code. You can see right here at this line, we are calling the check license key function. So this right here is where the check actually occurs. And this happens at 11EA. So this is an important address to remember. So just remember this address for now, and we'll get back to it in a moment. Anyways, so what we want is we want the check license key function to return 1 instead of 0. And again, let's assume that it's checking a license against some kind of internet database, and the internet database itself is what's actually returning 1 or 0. So what's going to happen is when it returns 1, we're going to get a shell because our license key is valid. So again, somewhere in the assembly code, we do see like a call instruction occurring, and that call instruction will have the address of our license key function, the check license key function. So, just thinking about this, what if we were to patch this instruction so that this call instruction right here points to some other function instead? Like, what if we were to point it to the PLT of an external function? If we do that, then we could use the LD preload trick to load up a malicious version of that external function. And then we would have our code be executed instead of the original code. So our code could just do something like have a single line that says return 1. So it'll just always return 1, even if the function is invalid. Or sorry, even if the license key is invalid, it's just always going to return 1. So here are the steps that we need to go through in order to use the LD preload trick to hook the function. And again, this is just one way of using the LD preload trick to hook functions. There's multiple ways of hooking functions, and I'm just going over one method of doing that. So the very first thing we have to do is we have to find the PLT entry of a legitimate library function that's being used by the program. And it doesn't really matter which function we choose. We just have to make sure that we choose something that's not really that important to us. And we have to make sure that it doesn't change the overall, the overall logic of the program. Once we do that, we have to patch the call instruction that we found earlier. And we would make it so that instead of calling the check license key function, it would call our library function that we've chosen instead. Then we would create a malicious library that also contains the exact same function with the same name and the same parameters. And we'll use LD preload to load that malicious library in there. So to do the very first step, we can just go back into our program right here. And to find PLT entries, we could just use object dump dash DJ, and then we'll grep for PLT. So what this does right here is the dash J dot text just searches only inside of the text section of the binary. And grep just make sure that we're only printing out lines that contain a PLT entry. So these are the PLT entries that we could be using for our exploit. So what we're going to be doing is we need to choose one of these PLT entries. And the one that I'm going to be choosing is this underscore CXA finalize PLT entry. The reason I'm choosing that PLT in particular is because it's not going to really change or modify the overall logic of the program. It's just there to, if you want to read about why this function exists, you could go to this website right here and take a look at that. It's not really important what this function does, because all that matters for us is that it doesn't modify the overall logic of the program, and it doesn't really change anything. If we were to overwrite this function, nothing bad would happen. Whereas if we were to overwrite something like printf or fgets, it could it will change the logic of the function and make make something bad happen potentially. So the next thing that we have to do is we have to patch the call instruction. So let's just go back into our code. And I already went over patching in the previous video, so you all should know how this works. We just open up the binary. And again, RB plus mode, read and write in binary mode. We'll say our data is the a byte array. And I already figured this out for you all, but the byte array that we're going to be using is, I'm typing it out right here. It's going to be hex E8, hex 81, hex FE, hex FF, hex FF. And this right here is the instruction for calling this this PLT entry right here. So it's going to call this this function right here. So we're going to do f.seek. And remember earlier I mentioned that we needed to remember an address. It was this address right here, this hex 11EA address, because this is where we are calling the check license key function, except instead of calling this this function, we're going to call another function instead, and we're going to overwrite the value of that function. So we're just going to overwrite that, and we will just write our data into there and just hit enter. And once we do that, if we take a look at the object dump for this now, if we go scroll up, we can see that instead of calling the check license key function, it's calling this function instead. So now that we have this library function that's being called, we can now use the LD preload trick to overwrite the text data that's inside of this this function, and then have it execute whatever we would like instead. So the way that we're going to do this is let's just make a file and we'll call it lib.c. You can name it whatever you want. It doesn't really matter what the name is. Make sure you include this stuff. And so the function that we're overwriting is the int CXA finalize function, and it does take in a void parameter. So make sure that you have that void parameter right here. And we're just going to constantly return 1. So this is all it takes for us to overwrite the function. And when we use the LD preload trick, this function will be used instead of the original library function. So let's get out of that, and we'll use gcc-shared. So what this command right here does is shared means it'll make a shared library file, so a .so file instead of a your typical executable ELF file. And -fpic, make sure that pi is enabled, position independent code. So we go ahead and hit enter, and now we have this lib.so file that's been created. So all we have to do now to actually load this file when we execute the program is do ld preload, and I already have it written out right here. We're going to do ld preload equals, and then the current working directory / lib.so, because lib.so is the library that we just created. So this is going to become the preferred library, and whenever there's two functions with the same name, the function that's inside of this library will become the preferred function over the other functions. Then we're just going to execute the program while we do that. So we go ahead and hit enter. It's going to ask us for our license key, but it doesn't really matter what we enter in here because we can just hit enter and we're going to get a shell regardless. So again, what just happened was we overwrote this function right here first. Before we even overwrote it, we patched this instruction so that it would call this library function here instead of calling the function that was actually being used to check the license key. And once that occurred, we overwrote this function using the LD preload trick. Because it's an external library function, it has a PLT entry and it has a function that we can overwrite. So we just overwrote that function. Our function just constantly returned 1 without even checking whether the license key was valid or not, or checking against some database. It just returned 1 automatically. And because of that, because it returned 1, we were able to get a shell as if we typed in the correct license key.